In this video, we will discuss critical points and local minima and maxima of a function. Now, if we are given some function f of x, a critical point just means that the derivative of our function at this point is either equal to 0 or it's undefined. When the derivative is equal to 0, the tangent line is horizontal. And when the derivative is undefined, well, there are actually a number of ways that this can happen, but the most common examples that we encounter in calculus are when the tangent line is vertical, so the derivative blows up to plus infinity or minus infinity, or our function has a kink, also called a cusp, and this is where the slope suddenly changes at this particular point. And in practice, when we want to find critical points, we are usually given some formula for a function f of x, so we just need to compute the derivative and check where this derivative is equal to 0 or it's undefined. For example, it blows up to infinity if we divide by 0. Now, if you look at all these different critical points, you can see that some of them can be local maxima, some other can be local minima, but some critical points may be neither local maxima or local minima. So when we are looking for local maxima and minima, first we have to find all the critical points, but then we have to check what happens at each particular point. So for example, if we are looking for local maxima, we have to check that the function is increasing up to this point and then decreasing after that. So the derivative changes from positive to negative as you cross this point. And if you look for local minima, you have to check that the derivative changes from negative to positive. Now finally, when we optimize a function on some interval a,b, for example on the interval between -7 and 7, the endpoints of this interval are special cases, because the endpoints are usually not critical points, but they are often local minima or maxima. So when we are trying to optimize a function on some interval a,b, we have to check what happens at these endpoints separately.